dear students. My name is Shivani Trivedi, and in this video, we are going to discuss how to convert SR flip-flop to D flip-flop. These are the outlines of today's topic. So, to convert any flip-flop to another flip-flop, we need to follow these three steps that we already discussed in our earlier video. That whatever destination flip-flop is there, for example, here destination flip-flop is a D flip-flop and SR flip-flop is a source flip-flop. So you need to follow these three important steps for conversion. So for destination flip-flop, you need to consider so for destination flip-flop, you need to consider this truth table that I have already made here. For that truth table, you need to you need to construct or you need to make some extended excitation table for destination flip-flop. For reference, here I have made two tables, truth table of D flip-flop and excitation table of SR flip-flop. D flip-flop is our destination flip-flop and SR flip-flop is our source flip-flop. Truth table for destination flip-flop, truth table for destination flip-flop is our D flip-flop. That is, as you are also aware that these are the transparent. D flip-flop is our transparent flip-flop. That whatever is your input, that will be your output. And this is the excitation table of SR flip-flop. Um, whenever you are taking this conversion table, you need to consider truth table that is also extended truth table for destination flip-flop. So it is easy to remember truth table of D flip-flop. D flip-flop, that these flip-flop is generally a transparent one. It is a transparent flip-flop, so, which means whatever will be the input, you get the same output. Its characteristic equation is equal to Qn plus 1 equals to D. And this is a excitation table of SR flip-flop. I am giving just short trick to remember. This is not a theory. I am just giving you a short trick that for S, you will see it is similar to Qn plus 1, 0, 1, 0. And here you can mark the cross. For R, it is just a reverse of S. So this is the excitation of table of SR flip-flop. If you are having truth table and excitation table, you can make the conversion table, which is made between the D, Qn and Qn plus 1. D actually extended table is that the I replace don't care with 0 and 1. Like here D equal to 0 and don't for Qn there is don't care. So first of all I write 0 and then I write 1. So for the same input, I am taking 0 and 1 both. Similarly, for 1 also, don't care 0 and 1 for don't care 1. What is Qn plus 1? You know the characteristic equation for D flip-flop, Qn plus 1 equals to D. So it is similar to 0, it is similar to 0, it is similar to 1, it is also equal to. So this is made by with the help of truth table of D flip-flop. Now, as I told you earlier that I have to make the extended conversion table, which is made by with the help of both the tables. So here I am writing SR, and this extended table is made with the help of excitation table of SR flip-flop. So excitation table of SR flip-flop is in this input is Qn and Qn plus 1 and output is S and R. So 0, 0 will give you 0x, 1, 0 will give you 0, 1 and 0, 1 will give you 1, 0 and 1, 1 will give you x. So this is a step 1. This whole is your step 1 and after this whole is your conversion table. This is called conversion table, which is made with the help of the truth table of the destination flip-flop and excitation table of a source flip-flop. After making the conversion table, you need to see this next come a step 2. In step 2, we have to make, according to the steps of the conversion, we have to make the K-maps. K map for what? K map for source flip flop, and source flip flop will be your SR. So here I am making the K map for S, and S for K map, we are considering the input variable D and QA. Then here I am considering K map for R. Now I am filling this 001X in this K map for S. 001X. I can make this pair, then the equation come S equal to D. Similarly, for R, I fill this column in the K map X100. So R equal to D. So now, by taking the expression which came from the K map, I design the circuit. So I have SR flip flop, SR. This is your clock, and I have to make D flip flop. So D कैसे बनेगा? S equal to D. I'm connecting S with D, and R is equal to D bar, and I am connecting R with. So this is the design of D flip flop using SR flip flop. D flip flop using SR flip flop. Similarly, in our coming video, we learn about more example of like SR flip flop using D flip flop, vice versa, JK flip flop using SR flip flop, SR flip flop using JK flip flop. So this whole comes like this. This is a circuit. This is the most frequent question in a university examination. These are the references you can refer for the conversion of one type of flip flop to another type of flip flop. Thank you.